Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendra Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra, a dynamic mathematics software, is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to visualize regular pyramids. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. I will show you what type of worksheet we will be showing to the children. We will tell them what is a pyramid, we will tell them what is a regular pyramid, and we will try to have the base as a regular pyramid. And a child can comment by changing the slider. He can have a different base: equilateral triangle, square, regular pentagon, regular hexagon, regular octagon, and so on. By changing the length of the side also, he can visualize it. By changing the height also, you can have a control over it, and he can rotate it and then check out the number of vertices, the number of edges, and so on. Let us try to design this dynamic worksheet from scratch. For that, I have taken a GeoGebra Classic 5 worksheet, geometry view, and in option I have taken rounding off to one decimal place, labeling of new points only. Let us start with the heading, regular pyramid. A child will try to ask so many questions in his mind. First question is, what is a pyramid? Now, a pyramid, we are discussing that it is a three-dimensional structure with polygon as the base. Then what is a regular pyramid? A regular pyramid will have the base as a regular polygon. Now you can ask the children that what are regular polygon, then number 3 side, number 4 side, number 5 side, and so on. Now remember, this GeoGebra is giving you a regular polygon directly. But if you have a control over the length of the side of the polygon, it is nice. Well, let us try to have a slider with A starting from 1 to 10 with increment 1 or 0.5 as per your convenience. This will be the length of the side. Now, I will go for a line segment with the given length whose side is A, which means that now I am having the liberty to fix the side of the regular polygon. By moving it, I can have the different length. Now I will go for drawing the regular polygon now. Go to the regular polygon. Have this variable side as its length of one of its side. Okay, now before we go for that, we have to fix the number of sides. For that, we should go for this slider. We will go for a integer small n. A regular polygon side always starts with 3, minimum 3. It starts with equilateral triangle and maximum any number, but I will go for only 10 for the time being. Increment as 1. Okay, now this n gives the number of the sides of the regular polygon. Go to this regular polygon. I am fixing the side of the regular polygon as this variable AB and the number of vertices as the variable n. Okay. Now you got a equilateral triangle. Now you got a square. You got a regular pentagon, regular hexagon, and so on. Now for this pyramid, you need height. Therefore, go to this slider. Then have a slider for height. H-E-I-G-H-T or small h, whatever you want. Minimum should be 1. Maximum I will have it as 10. And increment as 1. It is left to you. Okay, height also I got. Now go to this view, go to this 3D graphics. Now you are visualizing the base over here. Now GeoGebra is giving you an option to convert in a 3D graphics the base into a pyramid. Click this 3D graphics, then automatically the tools of 3D will open. Go to this pyramid. You extrude to pyramid, you click. What we are going to do? We are going to extrude the given base into a pyramid. What it wants? Select a polygon, enter the altitude. Simply select the polygon, got selected. The altitude, I want to have the altitude as the variable height. I think I got it. Escape. Height you remove, change it, it changes. The n I go for it, then it is also changing now. For I am now getting different pyramids with the base. If you want to show the children the base separately also, you can go for it. Now this is actually n is equal to 3, n is equal to 4 and so on. You can go for it object property for the polygon. You can give a color to it and you can have the opacity. So the child can understand that this is the base and then these are all the sides. Now at any spot you can ask the children to verify what is the base and ask them to verify it and how many vertices are there, how many edges are there and so on. Now let us try to have some more ideas about this regular pyramid. That is, we can go for the formula for surface area. SURFACE, surface area. Okay, the surface area formula is actually base area plus half into perimeter into slant height. It is base area. Therefore, now as it is having some latex formula, well, let us have it. Suppose if you want to have a space between it, then you should have a space. Therefore, it is base area plus, what is the formula for it? Base area plus half into perimeter into slant height. Half means latex formula, root this one into, you can go for this symbol, multiplication, perimeter. Okay, once again go to the symbol and go for this into slant. If you want to have a space, height. Okay, in the fraction you should have 1 by 2. That you can change it now. Okay, now you got it fantastic as you are writing it on the board. You see, half into, don't use this 1 by 2 slash and so on. Child will get confused. Now we should want the base area, we should have the perimeter, and we should have the slant height and so on. For that slant height, go to this 3D, go to this midpoint, touch any one of the side. For example, AB, I am just touching it. Okay, then go for this 3 dimension once again, go to this segment, join this and this. This is the slant height. Only one is enough, or the slant height. Slant height, 1 minute. Okay, now let us see what is this slant height looks like. It is segment S. That you have to remember. We need the formula. Okay, therefore go for this perimeter. How to get the perimeter? Very simple. Go and then click it. You got the perimeter. It is 20. You know that 4 into 5. Therefore 5 into 5, 6 into 6 and so on. Okay. Now let us try to display all of them. Now I will go for base area. Base area is equal to, from the object you go to poly 1. Select poly 1. Good. Poly 1, I got it. Okay. Base area is poly 1. Okay. Then perimeter. Okay. From the object I think perimeter poly 1. Okay. That also I got. Okay. Now slant height. I think from the object I think it was smallest. Oh, everything I got. Okay, this I can hide it. Okay, base area I got, perimeter I got, escape, perimeter I got, then slant height I got. Now go to this view, go to this input bar. Let us try to ask the GeoGebra to calculate capital S is equal to base area POLY1 poly 1. It is converted into blue color, which means that poly 1 formula is there, plus half into, therefore 1 by 2 multiplied by, what is the perimeter? It is actually n into a. You know that n into a, the number of the length of the side into side, therefore it is coming as 5 into 4, 6 into 4 and so on, into slant height, therefore multiplied by small s. Okay, I am entering. Good. Here go to this ABC and then SURFACE area is equal to Just now I have calculated. Come back and it is capital. Yes, good. I got it now. Surface area I got. Let us go for the formula for volume now. Okay, volume. Here also you need the formula in latex. For formula is equal to 1 by 3. Therefore, in the latex formula, you can go and have it 1 by 3. Okay, multiplied by in the symbol base area. You need a space, latex formula, space, area. Then again, you can go to the symbol, go to this multiplication into height. Good. In the A by C, you need 1 by 3. That is a formula 1 upon 3. Therefore, I am putting okay. Oh, I got the formula for volume. Here I can do the calculation. V is equal to 1 by 3, 1 upon 3 inside the bracket, multiplied by what is the base area? PO L by 1 multiplied by height HEAGHD. All are converted into blue color. Enter. Okay. Now let us try to display it over here. Therefore, volume is equal to capital V from the object. Oh, I got it. Okay, good. Okay. Now, a very simple idea, that is 1 by 3 into base area into height. Now, actually, all of them are converted into one decimal place. You have to remember. Suppose if you are rounding out of to two decimal place, automatically all of them will change accordingly. Therefore, you have to remember that. For base area into the height, for height we have keep it as 6. Okay, suppose if you change the height also, it changes and so on. Is it okay? Now, a child can come and visualize by changing the base, by changing the length of the side, by changing the height, and he can visualize everything. Now, not only that, by keeping it as right click, object property, here I have made n is equal to 3 to 10. You can have up to 20 or up to 50, whatever you want. Over here, it is a very interesting dynamic worksheet where a child can understand what is a regular pyramid, and he can have visualize different regular polygon as the base, and he can find out at every place what are the number of edges, the number of vertices, and so on. He can rotate it and then he can find. Thank you. Let us learn to lead.